Diffusion. In this session, you will be able to use diffusion to account for the movement of particles in liquids and gases, as well as state examples of daily effects of diffusion, and also to explain the effect of molecular mass and temperature on the rates of diffusion. Now, some examples of diffusion: when a bottle of perfume is left open for some time, the scent of the perfume soon spreads throughout the entire room. Similarly, if a mother is cooking curry in the kitchen, you will soon be able to detect the smell of spices in every room. Now, why is it so? This is because there's a process by which particles move freely to fill up any available space called diffusion. So diffusion is the movement of particles from the more concentrated region, which is, for example, the place where your mom cooked the curry, to all the rooms where it's a less concentrated region. So diffusion is an evidence of the kinetic particle theory. How do you show diffusion? We can show diffusion in the lab by placing a gas jar of air, which is colorless, over a gas jar containing bromine vapor, and bromine looks reddish brown. Now, after a few minutes after the cover is removed, the gas in both jars looks the same, which is a slightly reddish brown, not as brown as the bromine, but slightly brown, but throughout the entire both gas jar. Now, why is it so? It's because the air and bromine, they mix into each other, and hence they have equal concentration throughout, which is less concentrated than the bromine itself. Both air and bromine are made out of tiny particles moving at random, so they are in continuous random motion, and the bromine particles diffuse, spread out into the spaces between gas air particles. When the gas looks the same in both jars, it means that the particles of both gases are evenly spread. So the concentration of bromine and air in both containers now are same. We say that a homogeneous mixture of air and bromine is formed. Homogeneous means equal concentration throughout. Why does diffusion occur? Diffusion is a natural process. It's a movement of particles from a region of higher concentration to a region of lower concentration. And you must memorize this definition. Do all gases diffuse at the same rate? There are actually two factors that affect the rate of diffusion. First is the mass. So the mass of particles is called relative molecular mass. Molecular mass of some gases are, like, for example, hydrogen is 2. Why? Because each hydrogen is 1, so 1 times 2 equal to 2. And oxygen, each oxygen is 16, so times 2 equal to 32. Carbon dioxide, carbon is 12, plus 16 times 2 equal to 44. These are relative molecular mass of the molecules. The smaller the relative molecular mass of the gas, the lighter it is and the faster it moves. So the keyword is smaller relative molecular mass, faster it actually moves, diffuse faster. So memorize this. Gases with lower molecular masses diffuse faster than those with higher molecular masses. It's similar to a person with a lower mass, a lighter mass, can run faster than a heavier person. Okay, for example, in this setup here, okay, how do we show that the diffusion is affected by molecular mass? One side we have a concentrated ammonia, the other side is concentrated hydrochloric acid. Now, ammonia formula is NH3. So NH3 equal to 14 plus 1 times 3 equal to 17. And HCl is, hydrogen is 1 plus 35.5 equal to 6.5. So obviously, hydrogen chloride has higher molecular mass compared to ammonia. So ammonia, having a lower molecular mass, travels faster, okay, compared to the hydrogen chloride. Hence, ammonium chloride is formed further from the ammonia solution. So you move faster in this way, travel longer distance at the same time, while hydrogen chloride, hydrochloric acid, which is hydrogen chloride gas, diffuses at a slower rate, hence travel a shorter distance over the same period of time, and they will meet together to form ammonium chloride, which is nearer to the hydrochloric acid. Okay, let's try this question. Which statement about diffusion is true? Diffusion only takes place in liquids and gases. Diffusion shows that all particles can vibrate. Temperature has no effect on the speed of diffusion. Or particles of lower molecular mass diffuses faster than those of higher molecular mass. Now we just covered about molecular mass, right? Obviously, lower molecular mass diffuses faster than higher molecular mass. Answer is D. Now next thing, diffusion in liquids. Diffusion can also take place in liquids. For example, a piece of potassium manganate 7, and this is purple in color, is placed at the bottom of a beaker of distilled water. Deep purple solution forms at the bottom of the beaker when potassium manganate 7 dissolves. So as it dissolves, it starts to spread, the color starts to spread. So diffusion slowly takes place until the solution becomes uniformly purple. Okay, so first of all, the potassium manganate crystal has to dissolve, and once it dissolves, the concentration is highest at the bottom, and it slowly diffuses up until the concentration is homogeneous throughout. Temperature, effect temperature. What we observed with the experiment was repeated using boiling water. Not during boiling, but the water is already boiling water. It's very hot. Now you're not supposed to have external factor like, for example, heating while you are doing diffusion. When there's heating, there will be convection current, and convection currents, of course, it affects the speed which the substance will spread. Okay, but diffusion is a natural process without the influence of things like convection current and so on, or even fan and so on. So if the water is already hot and introduce a crystal inside, what happened? The solution will actually become uniformly purple in a much shorter time. So what does it tell you when the spreading becomes faster, diffusion becomes faster? The conclusion is, of course, when temperature increases, the rate of diffusion increases. So this is the second factor you need to remember. As temperature is higher, the rate of diffusion increases. So therefore, in a room, there's very higher temperature. For example, 35 degree in an enclosed room. Even there's no fan, alright? Someone spray perfume in front. The perfume will spread to the end of the room at a higher rate, okay, as compared to another room which is of lower temperature, let's say 20 degrees Celsius. So the higher the temperature, the faster the diffusion will occur. Okay, let's try this question. So the experiment was set up as follows. We have distilled water and copper sulfate. Now copper sulfate actually is blue in color, so you can see very obviously it's blue at the bottom and colorless distilled water is on top. Now it was observed that after leaving for several days, the liquid in the jar had the same color throughout due to the movement of water. Okay, first you must know that aqueous copper 2 sulfate, okay, it ionizes to form copper 2 ions and sulfate ions, and water remains as water molecule. So hence the movement of the copper ion and sulfate ions as well as water molecules, H2O molecules. Okay, these are the diffusion of these particles here. So answer is C, the movement of copper ions, sulfate ions and water molecules. Now you don't have copper atoms. It cannot be only movement of copper ions and sulfate ions only. Cannot be. Because when copper ions, sulfate ions move, how about the water molecules? They also move. And of course, worse still, copper sulfate molecules, it does not even exist. Copper sulfate that never exists as molecules. Now in this experiment here, bromine water and distilled water. Now bromine water, remember bromine is reddish brown. And the color can be quite dark reddish brown, it's very obvious. And distilled water of course is colorless. Now what happened after leaving it for some time? Of course, this bromine water is actually bromine molecules, and distilled water is actually water molecules. So the movement of the water molecules and bromine molecules actually results in a even color throughout, and this is diffusion. Okay, the next question, this is a very common question. Now what are we testing you here? Look carefully here. When gas Y goes inside these places here, gas Y, and there's gas X inside the porous spot, gases can diffuse through the porous spot in or out of the porous spot depending on the relative molecular mass. The lower the relative molecular mass, the faster it diffuses in or out. So let's look at gas X and Y. Now when there's no movement of water, the water remains at the same level, not going up or down. It simply means the rate of diffusion of X and Y are of same rate. I repeat. So when there's no movement of water in the U tube here, the water level doesn't go up or go down. It simply means that the rate of diffusion of gas X out of the jar compared to the gas Y into a jar, the rate of diffusion must be the same rate. Okay, the first thing you must know is the same rate of diffusion. Now, when will you get same rate of diffusion? You only have same rate of diffusion if they have same relative molecular mass. So let's look at the first one, option A. C2H4 and C2H6. Obviously, C2H6 is heavier, larger relative molecular mass compared to C2H4. There are 2 more hydrogen. How about, let's say, look at the second one, C2H4. C2H4, carbon is actually 12. So it's 12 times 2 plus 4. So CH2H4 is equal to 28. And N2 is 14 times 2 equal to 28. Now this looks like the answer, 28 for C2H4 and 28 for N2. So therefore they have same molecular mass and hence they should diffuse at the same rate. And when they diffuse the same rate in and out of the porous pot, the water level in the U tube should not move. Okay, how about the next one? Let's look at the next one. Carbon dioxide. Carbon is 12 plus 16 times 2 equal to 44. And C2H6. C2H6 is 12 times 2 plus 6 equal to 30. So you have carbon dioxide greater molecular mass compared to C2H6. The last one, 12 plus 16 equal to 28 compared to 14 plus 16 times 2, and this is obviously much larger than 28. So you only have the relative molecular mass for option B, where C2H4 is equal to N2. So since they have same relative molecular mass, they have same rate of diffusion, hence the water level in the U tube will not move. If, for example, if gas Y diffuses in faster than X diffuses out, then when Y diffuses in faster, in other words, the pressure will go up inside the porous pot. The pressure will cause the water level on the left hand side to move down and the right hand side to move up if Y is less molecular mass compared to X. But of course this case here is that when there's no movement, means that they must be the same. Answer is B. Let's try the other question here. Now there's again similar setup, and you want to have a movement, downward movement at X. So in other words, water level must go down. For water level to go down, the N must diffuse in faster compared to the M diffuse out. So I use a bigger arrow to show that it's faster as compared to M diffuse out. So in other words, M must be greater molecular mass than N. So N must be lower molecular mass compared to M, so it can diffuse in faster. So which one will it be? So let's check the molecular mass. Fluorine is 19 times 2, 38. Argon is 40. NO is of course 14 plus 16, 30. C2H4 is, carbon is 12 times 2, 24 is 28. Carbon monoxide is, C is 12 plus 16, 28. N2 is 28. CH4, carbon is 12 plus 4 is 16. This oxygen is 16 times 2, 32. You want N to be less than M. So which one is N less than M? N less than M, of course. Okay, let's see. This M more, okay, sorry, wrong side. This is N more than M. N less equal more. So you want your N to be less than M. Answer is B. Okay, for B, my N is 28, M is 30. So my N will diffuse into the jar in the pot, diffuse into the pot faster than M can diffuse out. And because when N diffuse in faster, you build up the pressure inside the pot, and it causes the water level at X to go down. So answer is B. Okay, now this is easier question. You just need to work out a few. Carbon monoxide formula is CO. CO is 12 plus 16 equal to 28. Now, what is placed inside P such that Q will go down? Okay, for Q to go down, it means that the gas must diffuse in faster than the gas diffuse out. Okay, the arrow is bigger going in than diffuse out. So in other words, my CO must be lower molecular mass, MR, CO must be less than P. Alright, so who has higher than 28? So the first one, ammonia, is 17, 14 plus 3. Remember the formula ammonia. Nitrogen is 28 because N2. Ethene actually is C2H4. And this one adds up to 28 also. Oxygen is 32. Okay, you want the P to be higher than 28, and there's only one answer. Answer is oxygen. So what happens is, oxygen with a mass, relative molecular mass of 32, higher than 28, hence the diffusion in is much faster than the diffusion out. So once carbon monoxide diffusing faster, you build up the pressure, and the pressure will cause the water level at Q to go down. So answer is D.